Our today's topic is all about a very important terminology of our syllabus, uh, electromotive force. In short form, we say EMF, right? So, considering this term, we will be discussing an example first. For example, we have a circuit like this, in which we have a lamp as a load and a battery, right? So this is the battery of, let's suppose, 12 volts, right? So this battery has some energy. That energy is used to push electrons in the circuit, right? It is measured by the energy dissipated by the source. Battery is equals to 12 volts, and it is the energy which we consider it in driving a unit charge around the complete circuit. Or the electromotive force of a cell can be defined as energy supplied to each coulomb of charge within it. In this particular battery, we have number of charges, and these number of charges need to be pushed into the circuit in order to glow this lamp, right? When the charge is start moving in the circuit, the energy that is carried by the charge will be utilized by this lamp, and that electrical energy will be converted, will be transformed into light and heat energy, right? So
Yeah.
light energy or heat. So when we will be considering the potential difference of the voltage of a source, source can be a battery, a cell, and a power supply, right? So when we will be considering the potential difference of
Yeah,
source
it
of
can.
the circuit, so that potential difference will be called as electromotive force. I'm repeating the definition again. It is defined as the energy dissipated by a source. Source can be a battery, cell, or a power supply. In driving a unit charge, around a complete circuit. And the force is called electromotive force. Look at the formula here. EMF equals to energy supplied by the cell divided by charge flow through the cell. We can write energy supplied to the cell with the work done, because when the charge is moving in the circuit, obviously it will do some work as well. So energy supplied by the cell equals to work done, and the charge will be for that flow through the cell. Uh, Capital E is the notation for work done. We can write W as well, or capital E as well. Charge notation is Q, and EMF notation is, this is called E. So the unit of the EMF will be joules per coulomb. Collectively, we call it as volts. Right, Daniel? Any confusion about it?
It's clear, Tila.
It's clear, right? So when we want to connect the cell of EMF of 1.5 volt, for example, I have three cells of 1.5 volt, and all these three cells are connected in series. How we get to know that these cells are connected in series? Because they are connected on a single line, right? So this circuit is called series circuit, and we want to find out the combined EMF. We want to find out the combined EMF. So we need to add all the individual EMFs of each cell in order to find the combined EMF of this of the circuit, that will be equals to 4.5 volts, right? When we want to connect cells in parallel, so the connection would be like this: cell 1, cell 2, cell 3, right? And all these cells are connected in parallel. So the combined EMF will be equal to one individual cell of the EMF, which is 1.5 volts. So in parallel, we don't need to add the EMFs. We just know the EMF of an individual cell that will be equal to the combined EMF, right? So this is how we can connect cells in series and in parallel. We need to know how these cells are connected in these particular combinations, right? So try to do this. Calculate the EMF, combined EMF of the falling cell. So Daniel, we have this one, this branch, and we have this branch in which we have uh, three cells of 2 volts. So first of all, we need to solve this branch. So 2 plus 2 plus 2 will be equal to 6 volts. So we can simplify this circuit like this, a cell of 6 volts. After that, the second branch, again, all the 2 volts will be added. Third branch, 6 volts. So now it becomes a series. It becomes a parallel circuit, right? So in parallel, the combined EMF will be equals to 6 volt, the EMF of individual cell equal to the EMF of individual cell, right? So it's a series parallel circuit. Now, the advantage of connecting cells in parallel. So we must know the advantage. The first, the cell will be last longer before they need to be replaced. In parallel, the life of a cell would increase, and we don't need to replace any cell. So, and a higher current will be can be supplied. So these are the advantages of connecting cells in parallel. Whereas the disadvantage of connected cells in series is when one goes down with some problem, the other would not work also. So this is the disadvantage of connected cells in series. Like, but in parallel, if one cell goes down, the other would easily work. There will be no effect of this cell which is not working, right? Yes, Daniel, got it?
Yeah, it's clear till now.
Okay. Now, what is potential difference, or we can say voltage? So again, we will be considering a circuit in which we have a lamp. We can include switch as well. So, right. So if the switch is closed, so the path of the circuit would complete. So the current can flow now. So when electrons flow in the circuit, pass through the lamp will glow, right? And energy that is carried by the cell is consumed or utilized by the load in the circuit. Load can be a resistance, lamp, or heater. When charge flow through the lamp in a circuit, the energy is converted into other forms, as I told you in the last slide, heat, or it can be converted into uh, light as well. So, what is the definition of a potential difference? Read it out, Daniel.
The energy converted per unit charge, yeah. The energy converted per unit charge passing through a component is called potential difference. PD.
Yes. So how we can define, how we can explain this? The energy converted per unit charge passing through a component is called potential difference across the component. How we can explain this definition?
Uh, uh, like the energy supplied to move like 1 unit of charge through the circuit.
Yes, when charge passes through the lamp or any load, so the voltage drop on that particular component will be the potential difference of the component, or the PD. The potential difference across a component in a circuit is given by the work done in the component, charge passed through the component, PD equals to W upon Q, right? So whenever we want to find out the voltage drop across any component, so we will connect a voltmeter. We will connect voltmeter, right?
Yeah.
Parallel to the component. We all know that voltmeter is an electrical instrument that is used to measure voltage in a circuit, right? So if we want to find out voltage drop across lamp or across heater, across any resistance, so that voltage will be called potential difference, right? Or we can find potential difference across any 2 points in a circuit. But whenever we want to find out the EMF across a source, so across a source, so we again connect voltmeter parallel to a component, electronic component. So the voltage that is across a source, that voltage will be called EMF, and the voltage that we will be measuring across any component, that voltage are called potential difference, right? So the formula would be same. Daniel, potential difference W upon Q as an EMF, W upon Q. The SI unit for both is same. Electromotive force has a SI unit of volts, and potential difference has an SI unit of volts. So potential difference across a component in circuit is measured by voltmeter connecting parallel with the component. The unit of the potential difference is volt, right? You can see the diagram also I have drawn in the previous slide as well. So you can see here as well, and this is the voltmeter that is present in the laboratory. And can you tell me what this single line represents beneath this letter V? What is this single line represents?
I'm not sure.
Hmm?
Yeah, I'm not sure about that.
DC voltage. DC voltage, right? There are two types of voltages, DC voltage and AC voltages. The single line will represent DC voltages, and this type of symbol is called as AC voltage, right? AC voltage. Can you tell me the range of this voltmeter by
From
looking at
0
this? Yes.
to
Tell me
5,
please.
yeah, 0 to 5
Yes,
volts.
0 to 5 volts. The maximum volt that it can be measured is 5 volts. 0 to 5. So this is the range of the voltmeter. So first you must copy these slides. Uh, Copy it, please.
And basically, how we can define it in terms of the battery. We also learned about
Yes.
voltage as well, and how to calculate voltage in series or parallel circuits.
Mm.
Uh, Also, we learned that how we collect a voltmeter as well. We connect it in parallel only.
Mm.
We also learned about the advantages of connecting a circuit in parallel compared to series, like the cells
Mm.
last longer. And I think that's pretty much it. Yes,
Mm.
we learned the formulas too. Anything else I missed?
Advantages connecting cells in parallel. What are the advantages?
Oh yes, it will last longer and
Hmm.
higher current. The cell
Higher
will
current
last
can
longer
be.
before they need to be replaced, and a higher current can be.
Okay. And
And the disadvantage of series is if one component breaks down, then the whole circuit breaks down.
yeah, the whole circuit will break down. Right. So wait for a minute.
No problem.
Now look at the syllabus here. What we have covered today. We have already discussed, know that electric current is related to the flow of charge. Second point, describe the
No,
use of ammeter,
okay.
analog and digital with different range. Already
I
covered
think yeah,
this.
we have done. Yeah, we did this.
Yes.
Electrical conductors, metals in terms of yeah,
Uh,
already this is done. Difference between
the
direct current, alternating current. This I'm not sure of, but I don't think we did before.
question part four, we haven't done this. The difference between direct current and alternating current, inshallah, I will tell you in the last class.
Hmm.
The formula for the current is next class, sorry. For the
No problem.
formula of current,
Oh
I equals
yes,
to Q over T. The
charge over
formula
time.
for charge over time.
Passing a point per unit. Yes, columns per time.
And in the
Then state that
part
the
six,
conventional current,
hmm,
positive, negative, flow of electrons. Okay, also six is clear. So all these points are
yes.
clear to me. Just four we didn't do yet.
4 billion, yes. And 4.2.3
Hmm.
now, electromotive force and potential difference. Define definition of electromotive force as
Yes,
electrical
we have
work
done
done
that.
by a force in moving a unit charge around a complete circuit. Know that EMF is measured in volts.
Okay,
Point number
exactly.
three,
Yeah.
potential difference
Hmm.
as the work done by a unit charge passing through a component. Know that potential difference between 2 points is measured in volts.
Also,
Describe the use of voltmeter formulas. Alhamdulillah, we have done this as well, right?
uh,
To
oh,
4.2.3.
this is all done. Yes,
Yes.
all of it is
So,
done.
yes. And now in the next class, in tomorrow's class,
4.2.4
we will be
resist.
discussing 2.4.2 resistance. So we will be following it step by step, topic to topic,
No
inshallah.
problem.
So after the completion of this whole section, we will go for past paper questions as well.
Yes, of course. Topical,
Okay.
whatever.
Okay. That's
Yeah,
all for today, Daniel.
no problem.
No, okay. Thank you. Allah Hafiz. Take care.
Other than Allah Hafiz, sir.
Allah Hafiz.